Hello everyone and welcome to Calculus lesson number 60. This is going to start us off with section 5.1, looking at natural log differentiation. So we are going to jump right in and define the derivative of the natural log function. Let's let u be a differentiable function of x, and if that is the case, then we have these two definitions, and both of these should be included in your formula sheet, but if you want to write them at the top of your notes for today just to have them handy, not a bad idea. So the first definition that we have is that the derivative with respect to x of the natural log of x is just equal to 1 over x. And then when we have the derivative with respect to x of the natural log of u, where remember u is a differentiable function of x, what we're really doing is using the chain rule. So here we would take the derivative of the natural log function, which would be 1 over u, and then times the derivative of the inside, which would be du dx. And we can also write this, the derivative of u we can say is u prime over u. So again, we have these two important formulas that we're going to be using for the rest of today. So let's jump right into our first example. Example 1, find the derivative of our function f of x equals the natural log of 2x. Because this is more than just x on the inside, I'm going to think back to my definition that the derivative with respect to x of the natural log of u, where u is a function of x, is equal to u prime over u, or using the chain rule, 1 over u times the derivative of u. So same thing, just two different notations. So here my inside function, or my u, is going to be this 2x, which makes our u prime just equal to 2. So taking our derivative, f prime of x, u prime over u would just be 2 over 2x, and then our 2's are going to cancel, so we can write our derivative, f prime of x, as 1 over x. Okay, example 2 is pretty straightforward as well. Here we have our function f of x is the natural log of 2x squared plus 4. Again, there's more than just x on the inside, so let's remember that the derivative of the natural log of u is equal to u prime over u. So let's identify our u as our whole inside function. U is 2x squared plus 4. That makes, our u prime equal to just 4x. So when we go to find our derivative, f prime of x, we are really just filling in our u prime over u. So u prime is 4x over u, which was 2x squared plus 4. And then we can simplify this a bit. So let's leave this as 4x over, taking out our 2. We're left with x squared plus 2. So we can simplify our derivative, f prime of x, by canceling our 2 and our 4. This becomes 2x over x squared plus 2. So those first two are our most basic examples of taking the derivative of the natural log of some function. Okay, when we take a look at example 3, we want to find the derivative of the function f of x equals x times the natural log of x. It looks simple at first glance, but really it's going to be a lot more fun because we have x, which is a function of x, times the natural log of x, which is another function of x. We're actually multiplying two functions together, so in order to find the derivative, we have to use our old friend, the product rule, which you hopefully remember is the first times the derivative of the second plus the second times the derivative of the first. And if you forgot it, it is on your formula sheet. So when we go to take our derivative, f prime of x, we're going to keep our first function x, and then multiply by the derivative of our second function, and the derivative of the natural log of x is just 1 over x. Then we will add our second function, the natural log of x, times the derivative of our first function, and the derivative of x is just 1. Now we can simplify wherever possible, so x times 1 over x, our x's are going to cancel, and we're just going to be left with 1 plus, and then the natural log of x times 1 is just the natural log of x. So we can write our derivative f prime of x as just 1 plus the natural log of x. So again, example 3 looked simple, but because we were multiplying two functions of x, we actually had to bring back our old friend, the product rule. Okay, and I bet you guessed it. In example 3, we saw the product rule. In example 4, we're going to take the derivative of a function f of x equals the natural log of x divided by x, which means in order to take this derivative, we're going to have to bring back an old friend, the quotient rule. So hopefully you remember, in order to take the derivative of a quotient, you have to identify your numerator function and your denominator function. And then our derivative, f prime of x, will be equal to our denominator, x, times the derivative of our numerator, and the derivative of the natural log of x is just, 1 over x, minus our numerator, the natural log of x, times the derivative of our denominator, and the derivative of x is just 1, and that's all over our denominator, which is x squared. So big TBT to the quotient rule. Again, if you forgot it, it should be on your formula sheet. From there, we just want to simplify whatever we can. So just like in number 3, we have x times 1 over x, so our x's cancel. So we are just left with our derivative f prime of x is equal to 1 minus the natural log of x all over x squared. Now this one looks a little bit different. Example 5, we're finding the derivative of a function f of x equals the natural log of x raised to the third power. So in this case, we're actually going to be looking at a chain rule and bringing back our power rule. So here we're looking for an inside function and an outside function. Hopefully you agree at this point, our inside function is this natural log of x, which makes our outside function this something to the third power. So when we go to take our derivative, f prime of x, using the chain rule, we'll start by taking the derivative of that something to the third power. So bring our 3 down, bring it to the second power. We can leave our inside the same as the natural log of x, and then times the derivative of the inside function, and the derivative of the natural log of x is just 1 over x. And then again, just simplifying, f prime of x would be equal to 3 times the natural log of x squared all over x. So in those first 5 examples, we looked at very basic how we take the derivative of the natural log function using the chain rule, the power rule, the product rule, and the quotient rule. If you have any questions on those first 5, now would be a great time to pause the video and ask your teacher before we move into some more complex examples. So now that we've seen the first few basic examples, in the next few examples, we might need to rewrite our functions before we can differentiate. So we're going to be using the properties of logarithms that we reviewed in our last class. So if you need to grab your notes from our last class, please go ahead and do so now. Okay, so here we go with example 6, finding the derivative of our function f of x equals the natural log of the square root of x plus 1. Hopefully by now you recognize my very first step is going to be to change that radical to be an exponent. So I'm going to rewrite my function f of x as the natural log of x plus 1 to the 1/2 power. Now, like I just said, we're going to have to use the properties that we've recalled in our last class in order to simplify these. So one big property of logarithms is that you can move an exponent to the front. So in an additional rewrite step, I'm going to write my function f of x as 1/2 times the natural log of x plus 1. So now my 1/2 has become a constant multiple, and I can handle the derivative of the natural log of x plus 1 like I just did in the first 5 examples. So when I take my derivative f prime of x, my constant multiple 1/2 is going to stay, and now I can handle the derivative of the natural log of x plus 1, and in this case, I'm going to want to remember that the derivative of the natural log of u is equal to u prime over u, so a basic chain rule here. I'm going to let u, in this case, equal x plus 1, which makes u prime just equal 1. So the derivative of the natural log of x plus 1 is going to be 1 over x plus 1. So we can write our final derivative, f prime of x, as 1 over, and then we can either write this as 2x plus 1 or 1 over 2x plus 2. So again, our problem looked intimidating at first because it had that radical. Once we rewrote it as an exponent, we recognized that property of logarithms. We could move it to the front. Then it became a constant multiple, and we were able to handle the derivative of the logarithm the way we did in the first 5 examples. Okay, for example 7, we want to find the derivative of our function f of x is the natural log of x times the quantity x squared plus 1 squared. At first glance, very intimidating because there's a lot happening, but if I use the properties from our last class, I can break this down and simplify it until I can take simple derivatives like I did in examples 1 through 5. So the first thing I notice is that inside my natural log, I have the function x being multiplied by a function x squared plus 1 squared. And I remember that my properties say if I have multiplication on the inside of my logarithm, I can split it into 2 logarithms using addition. So that is what I'm going to do. So let's rewrite our function f of x as the natural log of our first function x plus the natural log of our second function x squared plus 1 squared. Already looking much simpler, but hopefully you recognize that we have an exponent just like we did in our last example, and we can bring that exponent to the front. So in an additional rewrite step, we can write our function f of x as the natural log of x plus 2 times the natural log of x squared plus 1. Now that we've completely rewritten our function, we can take the derivative of each piece independently using the methods that we talked about earlier in this video. So taking the derivative of f, we get f prime of x is equal to the derivative of the natural log of x, hopefully you remember is just 1 over x, plus this 2 is just a constant multiple, just like it was, or just like we had in example 6. So we can keep that 2. Now all we have to do is worry about taking the derivative of the natural log of x squared plus 1. Again, let's remember the derivative of the natural log of u as a function of x is just equal to u prime over u. In this case, our u is going to be that inside piece, x squared plus 1, which makes our u prime, the derivative, just equal to 2x. So the derivative of the natural log of x squared plus 1 would be u prime, which is 2x over u, which is x squared plus 1. And in our final step, we can write our derivative f prime of x. Just multiplying that 2, we get 1 over x plus 4x over x squared plus 1. So again, our problem started out looking intimidating. Once we separated it and moved that exponent in front in all of our rewrite steps, we were then able to take the derivative of each piece using the methods we talked about throughout this video to come up with our final answer of 1 over x plus 4x over x squared plus 1. Okay, just a couple more. I'm going to start to move a little bit more quickly through the properties portion as I know you guys practiced over the past day or two. But if you have any questions as we're going through, feel free to ask your teacher, pause the video, go back and take it slow. Here we want to find the derivative of our function f of x, which is the natural log of x times the quantity x squared plus 1 squared, all over the square root of 2x cubed minus 1. When I look at this problem, I immediately see inside my natural log 3 different pieces. I see the x, which is being multiplied by the quantity x squared plus 1 squared, and then being divided by the square root of 2x cubed minus 1. So I'm going to go ahead and rewrite this, separating each piece using either addition or subtraction, wherever appropriate. So my function f of x would be equal to the natural log of my first function x, because I'm being multiplied, plus the natural log of my second function, x squared plus 1 squared. And then moving to my denominator, I'm going to separate by subtraction the natural log, and I'm going to rewrite this as 2x cubed minus 1 to the 1/2 power. And then before I can take my derivative, I'm just going to go ahead and move any exponents to the front. So this function f of x is just the natural log of x plus 2 times the natural log of x squared plus 1 minus 1/2 times the natural log of 2x cubed minus 1. So a lot happening in those rewrite steps. If you need to pause the video or ask your teacher, please go ahead and do so. Otherwise, once you're with us at this step, we're going to go ahead and take the derivative of each piece. So our derivative f prime of x is equal to the derivative of the natural log of x, hopefully we're starting to remember, is just 1 over x, plus our 2 is still a constant multiple, so keep our 2. Taking the derivative of the natural log of x squared plus 1, remember the derivative of the natural log of u is just u prime over u. So in this case, our u would be that x squared plus 1, and I'm going to do this a bit in my head. So the derivative here, u prime would just be 2x over our u, x squared plus 1. And then for our last portion, we're going to keep that 1/2 constant multiple. And let's go ahead and take the derivative of the natural log of 2x cubed minus 1. Again, we're going to be using that natural log, or the derivative of the natural log of u, which is u prime over u. So the derivative of 2x cubed minus 1 would just be 6x squared over our u, which is 2x cubed minus 1. So I'm going to just take a second and pause and give you a chance to catch up or to ask any questions. And then once you get to this part or this point, let's just go ahead and simplify so it's a little bit less messy. So we have our function f prime of x is just equal to 1 over x plus 4x over x squared plus 1 minus, and then I am just going to simplify here, this 2 and this 6. So this becomes 3x squared over 2x cubed minus 1. So kind of an exciting looking final answer, 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. Okay, for our last example today, we want to find the derivative of the natural log of the cubed root of x minus 1 over x plus 1. So I'm going to do a rewrite step here where I take that cubed root and just make it the 1/3 power. So this is really my function, f of x is the natural log, of x minus 1 over x plus 1 to the 1/3 power. Now that I can clearly see it's a power, I'm going to bring it down to the front. So this is my function, f of x is just 1/3 times the natural log of x minus 1 over x plus 1. Now keeping my 1/3 on the outside, inside my logarithm, I have a numerator and I have a denominator, so I can actually split that into 2 logarithms. So this is my function f of x. Keeping my 1/3 on the outside, I'm just going to be careful to keep a large bracket so I know my 1/3 applies to both pieces of the natural log of my numerator, x minus 1, minus the natural log of my denominator, x plus 1. So quick rewrite step there. I've rewritten my function as 1/3 times the natural log of x minus 1 minus the natural log of x plus 1. At this point, we can go ahead and take our derivative. So I'm going to scooch this up here actually. So taking our derivative f prime of x, our 1/3 is a constant multiple. So I'm going to keep that on the outside. Let's start by taking the derivative of our first function, the natural log of x minus 1, Again, we're looking for that u prime over u. So the derivative of x minus 1 would just be 1 over x minus 1. Keeping our minus, let's take the derivative. I'm running out of colors. Let's take the derivative of the natural log of x plus 1. Again, this would be u prime over u. The derivative of x plus 1 is just 1 over x plus 1. From here, we've done all of our differentiating. Now we just want to simplify with a common denominator. Which in this case is going to be that x plus 1, x minus 1. So I'm going to write my derivative, f prime of x, is equal to, keeping my 1/3 on the outside for now, I would multiply by x plus 1 over x plus 1 and x minus 1 over x minus 1. This leaves me with x plus 1 minus x minus 1 all over x minus 1, x plus 1. Just some good old-fashioned common denominator. Let's distribute our negative through. So this becomes 1/3 on the outside, x plus 1 minus x plus 1, all over x minus 1, x plus 1. Forgot how much fun this could be. Our x's are going to cancel. We have an x and a negative x, but notice both of our 1's are positive. So this becomes 2 over 3 times x minus 1, x plus 1. So we can write and simplify our final answer, f prime of x, as 2 over 3, and you may recognize this x minus 1, x plus 1 as a difference of squares, so we can write this as x squared minus 1. So just a bit of simplifying fun there at the end for you. Okay, great job with these problems today. As always, if you have any questions, you can reach out to your teacher. Homework 60 is on page 325, and it is just numbers 41 through 59, only the odds.